Hi, this is a video about circling approaches, that is, instrument approaches reverting to using visual reference so as to make a landing on a different runway, visual circuits with prescribed tracks, VPTs, offset approaches, low-level and bad weather circuits. These are all rather similar and confusable procedures, but they're also very distinct, as I'll be describing. A circling approach is a type of instrument approach procedure that allows an aircraft to approach a runway under IFR, possibly an IMC, but requires a visual manoeuvre to align with and land on a different runway than the one initially approached. This is often necessary when the instrument approach does not align with the available runways due to terrain, obstacles, or airspace restrictions. Although the manoeuvre is visual, it's still an IFR procedure. An element of confusion I often hear is that because they're called circling, they entail a 90 or even 180 degree turn. This is not the case. A circling approach may only be an adjustment of a few degrees, and there are several examples of executive jets mishandling apparently quite small course changes but going unstable. It seems that a common cause is a lack of recognition of the dangers just because the turn is small and not considered a challenge. Circling approaches are used when the final approach course of an instrument approach does not align with the intended landing runway. The approach is designed for a runway that's not available or suitable due to length, wind, obstacles or other restrictions. The airport layout requires a turn after breaking out of clouds, e.g. a single approach serves multiple runways. Terrain, obstacles or airspace prevent a straight-in approach. Runway configurations require backtracking or landing from a non-straight-in angle. These issues are sometimes solved with an offset approach, which I'll be talking about in a minute, but the difference is that an offset approach has its own minima, such as this one at Le Bourget, while a circling approach uses circling minima within a protected area. The aircraft must remain within a defined circling protection area that varies based on an approach category. A circling approach has a defined circle-to-land minimum descent altitude rather than a decision altitude, meaning the pilot must descend no lower than the circling MDA and maintain visual conditions to complete the manoeuvre. The MDA is published in the AIP and jet plates for different speed categories. If visual contact is lost, a missed approach must be executed. The most important thing is that the pilot must maintain continuous visual contact with the landing runway or airport environment. In conditions of reduced visibility, that means a tighter radius turn and a lower height in order to be both below the cloud and in a position to land. The combination of low height, poor visibility and more extreme manoeuvres inevitably increases the risk of CFIT, colliding with terrain or an obstacle. It's imperative that if visibility drops or the runway is lost from sight, an immediate missed approach must be executed by making a climbing turn towards the landing runway. The pilot should make left turns unless otherwise specified on the approach plate or authorised by ATC. This confusingly means that the first turn is to the right to establish in a left-hand pattern. In our kinds of aircraft, use rate 1 turns, or only exceed them slightly if you need to fly the turn accurately. Pilots should generally enter the manoeuvre in landing configuration, gear down, landing flap set, and maintain it during the circling phase to minimise workload and reduce omissions. In aircraft where manoeuvring with landing flap can increase the risk of stall, the pilot should consider whether to land with approach flap. This is very type and runway dependent. Because the protected area is determined by approach speed category, the aircraft should be flown at appropriate speed as previously detailed, especially in poor visibility. Pilots should bear in mind wind drift when selecting circling tracks and stay within the protected area and inside the runway. Drift away from the runway can result in losing the runway in the murk, and drift towards the runway can result in overshooting the centreline and potentially unstable and unsafe manoeuvring on final. This usually means doubling the drift correction outbound to allow for drift in the inbound turn. If that carries a risk of losing the runway, you might consider a diversion to a runway with less crosswind. You shouldn't descend below the MDA until you can see the threshold and are in a position to make a normal landing on the intended runway. meaning that you should be turning to final as the descent is initiated. This also requires judgment, and my suggestion is to use constant aspect on a continuous turn onto the final approach, whether from downwind or some intermediate track if you're not doing a full reversal. Continuous aspect, which entails keeping a continuous slope, 3 degrees in IFR, is easy once you've grasped it, and you may have been taught to use it for forced landings, albeit at higher approach angles, but it's something worth practicing either on the aircraft or in a sim. You can practice in a normal visual circuit by starting a descent adjacent to the threshold and just keeping the visual aspect constant. If visual reference is lost before landing, or it's clear that the landing can't be executed safely, you must immediately execute a missed approach. Unless the approach plate says otherwise, the missed approach procedure is based on the initial approach runway, not the landing runway. The first action is to make a climbing turn towards the landing runway and overhead the airfield, and then to manoeuvre onto the missed approach track. This can be achieved either circling or in an S-bend. This can be a challenge as you may be pointing in exactly the wrong direction. This is a particularly hazardous exercise as you're low, slow, manoeuvring with bank applied and pitch up, gear and flaps deployed, and typically have no guidance. What could possibly go wrong? This is a recipe for spinning in, and your focus must initially be to gain speed and altitude, clean up when safe, and only when above the MDA consider how you're going to turn towards the initial approach course. This is a classic example where aviate, navigate, communicate is vital. Once you're pointing the right way, you can execute the missed approach. Obviously, if the missed approach entails a turn back, it makes sense simply to continue into that, once above MDA and still within the manoeuvring area. You should always have thoroughly briefed the missed approach, of course, but never more so than before a circling approach. A brief word about automation. You have the choice of using autopilot, flight director or raw data, and each has pros and cons. Most of our autopilots are restricted from use below 800 or 1,000 feet unless on a coupled approach, which does not include a circling approach. I'm sure someone will correct me in the comments, but I can't think of one GA autopilot which is permitted to be used any lower, and most circling approaches will be lower than that, so they're out of the equation. However, Flight Director is available. It has the advantage of giving you a single glance to check bank angle and altitude while you focus on visual references, so will help with disorientation. But Flight Director will reflect the settings made on the autopilot, so if you're going to use it, you need to both fly the autopilot and hand fly, which can be an increase in workload and be open to error. You have to ensure that the mode selection is correct. I would suggest using heading and alt modes until turning final, remembering to allow for double drift in the heading. But then what? Vertical speed and turning the heading bug, or having the visual approach set up and using the approach mode? To my mind, both these carry more disorientation risk than using raw data. But what you absolutely mustn't do is leave the flight director on heading and alt as you turn and descend. That results in a disorientating instruction to turn away from final and climb. So once you've stopped using the flight director, you must disable it. If you do need to go around, many autopilots have a toga button giving an immediate straight ahead and climb instruction, which is very valuable as you reorientate yourself and are cleaning up the airframe. Or, of course, you just use raw data and keep a very careful scan going of bank angle, heading and altitude. If you have bugs, I strongly suggest using them. Obviously, this is going to detract from your focus outside the aircraft, which may be reduced to glances. So, no correct answer, but my choice would be flight director in heading and alt until you start the continuous aspect turn to final, then switch it off and look outside, just glancing inside for airspeed. Some circling approaches are limited to daytime use only, so make sure you check the plate for that. If you do make a circle to land at night, you should be aware that some runway edge lights are much less visible from the side than from final approach, so, especially in poor visibility, you need to be very careful to keep them in sight. Visual cues are going to be considerably reduced and, of course, terrain will not be visible and obstacles only visible from their lights, which are notoriously difficult to judge distance at night. Personally, my aircraft avionics has a feature to provide 3D guidance for visual approaches to almost every runway, and I always set this up for the runway I'm going to land on, even in a VFR visual circuit, and, if workload permits, I'd certainly do the same for a circle to land. Bear in mind, if you're using heading and alt on the flight director, these modes won't be affected by having the HSI set up for a final approach, so you can load the visual approach for the landing runway as soon as you break off the IAP. But if you do that and go around into the missed approach, you will need to reload the original approach in order to activate the missed approach procedure for the original IAP. That's a lot of button presses in a short period when flying low and slow, and can contribute to the difficulties and dangers of a circling approach. And I also have SkyDemon running, as it provides yet more orientation assistance, though it's yet another thing to look at and can mean your eyes are pulled away from the runway and the panel, so it depends again on workload. So, in summary, circling approaches carry risk and challenges. Circling approaches have high workload entailing quick decision making, precise control and situational awareness. They carry a risk of spatial disorientation, especially if visibility varies or fluctuates. You may lose sight of the airport and immediately need to revert to instruments, and you must not hope that you're going to pop out again. You're either in the circling approach following its rules, or you're not, and if you're not, you must go into the missed approach immediately. The CFIT risk is high, so you must stick religiously to MDA, visibility and speed rules. It's easy to go unstable. You must ensure that everything is planned and going to plan, and be ready to throw it away. If you do go unstable in the final approach, you can consider making another visual circuit if the conditions permit, but then you must get an ATC clearance and think about how to make the second approach better than the first. So, having established that circling approaches are difficult and hazardous, we should address the question of whether they can be avoided by landing on the straight-in runway for the approach. My home base, at the time of making this video anyway, only has an IAP for one direction, though this is set to change very shortly. So when the wind is unfavourable, there's a circle to land to the reciprocal runway. I would say that at least half of the aircraft given an ILS to 2-1 with a circle to land to 0-3 end up landing on 2-1. This is both for operational reasons, it's obviously quicker and cheaper than flying a circuit, but also because the pilots are choosing the risk of a tailwind landing over the risk of a circle to land. So, before you start the procedure, you need to know whether a tailwind landing is in limits for your aircraft, its landing weight and the runway length. This may entail going into the graphs, so should be done well before you get there. Even if you decide that a tailwind landing is in limits, you may opt to do the circle to land, but then, if you reach the circling MDA and can't see the runway environment, you also know whether it's acceptable to continue to take the tailwind and continue the decision altitude for the approach, or whether to go around from circling MDA. On the other hand, if cloud base and visibility is not an issue, there's nothing to say that you need to descend to circling minima before starting the circle to land. Indeed, you may well simply descend to a circuit altitude and perform a normal VFR circuit if you're happy that there's no chance of re-entering IMC. Now, we're going to look at visual circuits with prescribed tracks, or VPTs. While with a circling approach, tracks are at your discretion, provided you stay within the protected area, in a VPT you must follow a specific predefined ground track. They're mostly used to ensure terrain and obstacle clearance and noise abatement compliance. In Europe, they're only common in France and to a lesser extent in Spain. The one most of us are most likely to encounter is Cannes, where the IFR approaches are northerly even for a southerly landing, but there are half a dozen others. Outside France, the other airfields in Europe I can think of which describe their approaches as VPT are A Coruña and Pamplona in Spain, Bolzano in Italy and Lugano in Switzerland, though there are plenty, such as Madeira and Sion, where it's described as a visual approach, but do have prescribed tracks and are therefore effectively VPTs. A visual circuit normally allows some flexibility for pilots to fly within a general pattern around the airfield. However, in a prescribed procedure, the aircraft must follow a strictly defined route, often with specific turning points, altitude restrictions, and possibly even speed constraints. However, unless it's specified otherwise in the procedure, you're only required to maintain sufficient visual reference to follow the prescribed track. You don't need to be visual with the runway until you need to start the descent below MDA. I think that they are mainly used for noise abatement, but also to ensure aircraft remain clear of terrain and obstacles. They're widely used in places like India, Bhutan and Nepal for that reason, and to provide spacing from other airport traffic or nearby controlled airspace. The exact route must be followed, either depicted by specified waypoints or visual landmarks, and that route is sometimes monitored for compliance. I'm not the only pilot to have received a rude letter from Cannes, I'm sure. There are usually altitude restrictions as well, possibly including step-downs, for noise, safety and separation reasons, and these will probably be monitored for adherence as well. Turns are normally prescribed at exact locations, but sometimes turns are prohibited until passing a designated point, e.g. no turn before passing the river. Some VPTs and visual procedures have quite low speed limits to manage spacing and prevent unstable approaches. There may be holding points, such as a specific waypoint or visual reference, where aircraft must be orbit until cleared. The main thing to say about VPTs is that they require careful briefing. I know so many pilots who've been cleared for the localizer approach at 17 at Cannes, and even when established on the FAT of 346 have still not twigged, and emitted a loud expletive as they lose all situational awareness at minima. Luckily, Luxus and Pbon are in the databases and in SkyDemon. But if you arrive at minima without even knowing the VPT exists, you're pretty much stuffed. You really need to brief and have situational awareness. Part of that briefing is that for VPT procedures, there's usually a missed approach. But that missed approach procedure may not take into account deterioration in IMC. So if the weather is marginal, you need the situational awareness to know how to deal with the loss of reference. Okay, the next thing I'd like to talk about is offset approaches. It's important to understand the difference between an offset approach and a circling approach. An offset approach is designated to the landing runway. So, for example, you might have a runway QDM of 247 degrees, designated runway 25, but the localizer orientated on 273 degrees, meaning a left turn of 26 degrees at decision altitude is still designated for runway 25. An offset instrument approach is one where the final approach course is offset by more than 3 degrees, but not more than 30 degrees from the extended runway centerline. If the offset exceeds 30 degrees, the approach is considered a circling approach. Having said that, it's still a circling approach even if the difference is less than 30 degrees, if the instrument procedure isn't designated for the landing runway. Indeed, in Europe, where sidestep manoeuvres are not defined, you can have circling approaches to parallel runways where ILS and both runways all have the same orientation. Offset approaches are usually used where terrain, airspace restrictions or obstacles lie in the direct path to the runway or provide insufficient lateral clearance. Normally, the expectation is that you'll make a straight-in landing. Because you need to manoeuvre before landing, minima are higher than for normal straight-in landings. Generally speaking, the procedure will cross the extended line at minima, meaning that you'll get the best view of the approach lights and runway environment from minima. That means, unlike a normal approach, if you were to continue straight once below minima, you'll be pointed to one side of the runway, and for that reason, the missed approach point is generally set at the point where the slope intercepts the MDA, so maybe 1 or 1.5 nautical miles before the threshold. When you reach minima, you need to decide whether you have adequate manoeuvring room and visibility to realign and land safely. If in doubt, go around. Of course, you always brief the missed approach, but it's especially important on the offset approach as a go-around is more likely because of a combination of higher minima, less familiar visual environment, and the need to go around if the visual manoeuvring doesn't work out. Finally, let's address low-level and bad weather circuits in Europe, which, unlike the circling approach, are VFR procedures. There's a slight difference between the two, though, to my mind at least, and bearing in mind that I'm not an ab initio instructor, that difference is fairly marginal. In that, a bad weather circuit is what you do for real, because the ceiling, visibility or icing makes a standard circuit impossible, whereas a low-level circuit is what you do in training to prepare yourself for that eventuality and for skill improvement. I think the military also use them for operational reasons like not being shot down. These circuits are flown at a lower height than normal visual circuits, either to remain below cloud cover or within visual range of the runway and poor visibility, while maintaining safety margins from terrain and obstacles. They're essential for continuing safe flight operations in deteriorating weather conditions at airfields without instrument landing facilities. Generally, they're flown between 500 and 800 feet AGL, only going lower in an emergency when no other options remain. A lower-level circuit is flown using the same visual cues as a normal circuit, meaning the circuit will be tighter and closer into the runway. That means everything happens faster, with reduced reaction time. You must also anticipate turns earlier due to lower altitude and reduced visibility. The risk of hitting obstacles is increased. You must be aware of trees, buildings, masts and power lines. Very often, the circuit will not have the same crosswind, downwind and base legs of the conventional circuit, but will be flown more as an oval, allowing you to keep a better eye on the runway and maintaining a constant aspect, and also allowing for micro-adjustments of the turn. This also means that an earlier turn from downwind through base to final will be executed to ensure that the final approach is stable with a normal perspective. Joining the circuit can be a challenge. Obviously, an overhead join is not possible, and I would advocate joining downwind at circuit height in order to get orientated before the base turn onto final. If a 45-degree downwind join is mandated, as in Germany and other European countries, you need to keep your eye out to ensure that you turn onto downwind far enough before the runway. This can be a real challenge in poor visibility, as the turn onto downwind will take you closer in. From a 45-degree angle, that's manageable, about 250 metres closer in, but from a 90-degree cut, using a rate 1 turn, which is the maximum I'd suggest given your low height and the dangers of disorientation and spinning, it's close to half a mile. I would suggest being fully configured for landing before you join downwind, at least as far as is sensible and permitted in your aircraft type. This saves configuration changes and the loss of stability and disorientation they can cause in poor visibility and low level. Different countries have different procedures and regulations. In the UK and France, they're generally at the pilot's discretion outside controlled airspace, though some altiports in France have prescribed special low-level circuits. In other countries, such as Germany, VFR minima are more strictly enforced. The risks of low-level circuits, especially in poor visibility or beneath a low and variable ceiling, are considerable. It's easy to get lost and be unable to see the runway, to get disorientated and lose track of bank angle and airspeed, potentially resulting in irrecoverable stalls or spins, to misjudge final approach angle and speed because of reduced distance and reaction time, to find yourself in cloud and tempted to go down to recover surface contact, to impact terrain or obstacles, mid-air collision with other aircraft caught out by the weather trying to get home. These risks are further compounded by the turbulence and wind shear associated with the weather conditions which create low cloud and poor visibility. For all these reasons, you must be careful to brief what to expect, elevation, terrain and obstacles, speeds and bank angles, and, most particularly, what conditions or circumstances will result in a go-around, change to IFR and or a diversion. This may be particularly challenging if you're not qualified to fly an IMC or the aircraft is not equipped. Of course, this is ironic because you're only likely to be doing this if IFR options are limited. So, all these procedures are risk-bearing. The circle to land is the riskiest IFR normal procedure, and the bad weather circuit flown in minimal conditions is risky. So all I can ask is that you avoid them when you can and are very, very careful when you have to do them in minima. I really hope to see you in the next video.